Welcome everybody. Welcome and thanks for joining us today. My name is David Bonifacic. I'm CEO of WB. Earlier this month, WB marked its 21st year in business, and during that time, we've all experienced so many changes in the workplace, from bench seating to now COVID. Following our previous office to lab repositioning presentation last month, many of the people on the webinar asked us to talk about hazardous materials and the impact on lab design. Today's presentation is about answering some of those questions. Just for everyone's knowledge, our presentation today is AIA certified. If you want credits, we will be sending a survey for you to fill in with your AIA number. And with that, there are 4 learning objectives that we'd like to accomplish today. With that, it's my pleasure to introduce 2 of our top experts in lab design, Ray Doyle and Andy Shanahan. Ray leads our nationwide life science practice, and he is the reason that WB is a leading expert in lab design. He has completed over 150 lab projects, and he's keep going strong with those projects. Andy is our code consulting expert. He has a good sense of humor to know what codes are something most people like to talk about, but he doesn't like to talk about, but he likes to talk about. He has a bachelor's and a master's in fire protection engineering, and I am fortunate to work with both Ray and Andy and to introduce them to you. Little housekeeping, please ask any questions in the chat. We'll answer them as we go along or at the end. And then 10 minutes before the end, we will unmute everyone to have an open forum to ask questions. So with that, I'm going to pass it on to Ray and Andy.
Thank you, Dave. I appreciate that kind introduction. As Dave said, today's presentation is about code consulting. We talk about the role of code consulting and its need and ability to help make our place of work safer, and people's ability to help save people in the event there is an event in a building safer. We gave a webinar a couple months ago about repositioning offices to labs. Today we'll follow up on that with a lot of stories and applications that apply to labs specifically. A little less about office space, but more about lab space today. The way I like to think about lab consulting and the investment that it takes to really analyze a lab building of approximately 100,000 square feet, you're looking at paying somewhere between $5 and $10 grand to do a code analysis. That is very inexpensive insurance to help protect you against many of the things we're going to talk about today.
So hello, thank you. So I'll do my best to follow up your efforts from last month, Ray, and provide a little more context on the specific hazardous materials related items that can really drive the decision-making process when designing a laboratory space. The goal of today is to make sure you all have an understanding of how critical your hazardous material inventory is to proper laboratory design, because of how significantly it can impact your goals of repositioning any space into a laboratory. Throughout my career, I've seen architects and engineers design laboratories and other areas with hazardous use without consideration to the hazards that will be housed there. Either these omissions are caught during plan review, which can result in significant cost increases and scheduling delays, or they get missed entirely, creating serious fire protection and life safety hazards that the building will not be equipped to prevent. Today, we'll touch on a few key code items that are related to hazardous materials compliance. We'll keep it high level and try to identify how these code requirements can really cause problems for your projects and what you can do to avoid these issues. We'll also discuss several case studies where projects were severely impacted by a lack of proper hazardous materials assessment early in the process. In each case, key hazardous materials compliance issues were missed, resulting in costly schedule and budget overruns. I should also point out that this is just a handful of situations that I've come across, as this stuff happens every day. The good news is the right things to do are relatively inexpensive and very easy if you know a few key items. And the goal of this presentation is to shine a light on how things can go wrong and point out how some of these easy steps you can make ensure these issues won't happen on your projects. The first item we want to talk about is how many different codes can apply to these spaces. Like any project, we start with the building code. And if you've done hazardous materials projects before, you're aware that there's a table in the IBC that regulates the quantities of hazardous materials that you can have in your building before you're considered a high hazard occupancy. These values can change based on a number of features of your space and the building itself. And it helps to have experience with these sections, as they can be a little overwhelming. But the building code is just the beginning of the standards that you need to comply with. In addition to the building code, all projects have to comply with the fire code as well. Now, the fire code gets less attention than it should during design, because for most occupancies, the key components of the International Fire Code are mirrored within the International Building Code. However, the fire code has a much larger impact on hazardous material jobs. For example, in the IFC, chapters 50 through 67 discuss specific requirements for specific hazards, from common flammable liquids to flammable solids, corrosives, cryogenic fluids, water reactive chemicals that may not be able to be protected by a sprinkler system.
Andy, could
These
you
requirements are often not found within the building code and must be carefully reviewed to make sure you're fully compliant.
Andy, if you don't mind, can you just walk us through a little bit what's a cryogenic fluid, and just so people understand a little bit of each?
Yeah, so cryogenic fluids are liquefied gases that are maintained in their liquid state via refrigeration. So liquid nitrogen and liquefied natural gas are a couple of common examples. As far as other examples, flammable liquids can include heptane, acetone, isopropyl alcohol. Combustible liquids consist of diesel fuel, mineral oil, oil-based paints. Corrosives are acids, hydrochloric sulfuric acid. And common water reactives include lithium, which, as you may know, is closely regulated on trucks and planes. And even your Amazon boxes will have warnings on them because they contain lithium batteries. And that's because when lithium gets wet, it can release hydrogen, which is so flammable it can lead to explosions. So each of these hazards has different ways of mitigation, different ways we have to deal with them, which is why the fire code has different chapters for each of them. The fire code will also have reference standards that are not referenced by the building code. Reference standards are sets of requirements that are not specifically within the text of the code, but rather are referenced by the code and contain extensive requirements for your specific hazards that may not be outlined in the building code. When it comes to, to make it more complicated, some jurisdictions adopt the IBC as their building code, but NFPA 1 as their fire code. And the reason this adds a level of complexity is that NFPA 1 is written by the National Fire Protection Association, while the IBC and IFC are written by the International Code Council. And these are essentially competing code bodies, and their codes are not coordinated with each other. They often will have differing and sometimes conflicting guidance. And when it comes to laboratories, one of the key codes that's referenced by NFPA 1 is NFPA 45. Now, I should point out, if your jurisdiction already adopts the 2018 international codes, they began referencing NFPA 45, but strictly for higher education laboratories. But NFPA 45 is written to protect all laboratory spaces that utilize flammable and combustible liquids. And many common solvents in all types of laboratories, not even chemical laboratories, fit this description. So if your jurisdiction adopts NFPA 45 directly or by reference, be aware, as it has requirements that are absent in the IBC that can really impact your project.
So Andy, a lot of times I think of the codes in two ways. You know, IBC is this day one code. You have to do all of your plans and all of your documentation for permit drawings in the form of IBC. And by reference, some NFPA codes. But the real reality, right, is in the day N, as you live in these spaces, the fire marshal at any time can come through the space and identify hazards and question how you're occupying the space. So it becomes the living code, if you will, if you think of the NFPA in the form of a living code, and the reasons that the fire marshal can do inspections once a year and come in and provide even fines, but definitely they can stop use of specific spaces to force them to be upgraded.
Yeah, that's correct. And now we'll discuss how those nuances can really impact your project as we go through the discussion today. The key point that we need to be aware of is your building and fire code, which ones are applicable to your project. But at the end of the day, whether it's IBC, IFC, NFPA 1, these are all general standards. And they all reference even more specific standards to handle more specific hazards. And that's where standards like NFPA 45, the standard for laboratories that use flammable combustible liquids, NFPA 30, the flammable combustible liquids code, or NFPA 654, which governs combustible dust hazards, can come into play. As we said, different hazardous materials create different hazards that require specific interventions that allow for the building and fire code to achieve their goals, which is to protect life and property and provide a reasonable level of protection for first responders. So not understanding this layered compliance environment can lead to significant design errors, resulting in life safety risks as well as costly project delays. Now, as Ray mentioned, hazardous material requirements are found in both the building and fire code. This creates additional challenges because these codes are enforced by different code officials and code inspectors. And in some jurisdictions I've worked in, the building department defers all hazardous materials compliance to the fire department, but typically you'll need to coordinate with both departments during your design to ensure nothing's being missed. Sometimes your initial plan review is robust, and other times plan review is not comprehensive, and things can get missed, resulting in discovery of issues in the field during a life safety inspection prior to certificate of occupancy. And none of us want to find out at final inspection that we're not compliant with our hazardous materials design. And this is why it's important to figure out your hazardous materials compliance strategy within your ownership and design team as early as possible, and then to present your strategy to code and fire officials as early as possible. And this will avoid issues falling through the cracks, which can be caught later when they're more costly and time consuming to repair, or worse, missed entirely, and your project has become a life safety risk and an ongoing liability.
So Andy, I've had a lot of different experiences with different projects through the years of doing lab projects for retrofits or speculative office or build to suits. And in some cases, the design is based on an NFPA 45 analysis and for chemical storage or flammable storage. And it's not specifically related to the IBC quantities. Are we allowed to choose NFPA 45 over IBC or vice versa? How does that work?
Yeah, that's a good question. And like a good engineer, I'll say it depends. It depends on the jurisdiction you're in and whether they're comfortable with an either or scenario. The default position for most jurisdictions where both codes are applicable is to mandate you comply with the more restrictive requirements of both. The building code, if you look at the chapter 1 of the building code, it defers to the more specific or more conservative requirement. That's just how the code works. And NFPA 45, for example, is definitely more specific than the IBC, as it's designed to control laboratory environments specifically. But it's often more lenient, and code officials may be skeptical. On the plus side, NFPA 45 has been around since 1974, and it has a good history of meeting its goal of limiting fire to a single laboratory. But you should have discussions with your code official because they may require some convincing, as it's likely a variance to avoid a IBC compliance.
And there's a question out there about NFP 45. What's the title? What is that about again?
NFPA 45 governs laboratories that handle flammable and combustible liquids specifically.
And whether it's commercial or schools, you said there was a difference between schools and commercial.
Yeah, well, in 2018, the IBC finally started regulating laboratories specifically, but the language in there is for higher education laboratories because the changes were driven by higher education stakeholders. And so it's not there for commercial laboratories yet, but so that's the only reference within the I codes to NFPA 45.
Gotcha, thanks.
So Andy, one more question for you. So in these buildings that are typically higher number of floors, we know that you get restricted by the quantity of chemicals, but is it true that NFPA 45 allows higher quantities of chemicals on higher floors?
Yes, well, it can, yeah. So NFPA 45 is often more lenient, especially on the upper levels, where the IBC can be very restrictive, which we'll talk about a little bit later on. But the difference between the two standards is that NFPA 45 is specifically focused on the laboratories themselves, where the IBC is a general code that focuses on the buildings on a per floor basis. And the stated objectives of NFPA 45 are to limit injury to occupants and emergency personnel, as well as to limit property loss to a maximum of a single laboratory. So if we think about those objectives, the differences in the strategy between the IBC approach, which was not written for laboratories, and the NFPA 45 approach, it makes a lot of sense. So NFPA 45 limits chemicals in a lab unit, but there's no restriction on the size of the lab units specifically. There is no limit on the size of a lab unit or the number of lab units per floor. And as far as NFPA 45's methodology is concerned, no matter how big the lab is, if it's designed properly, the fire will be contained. So one way NFPA 45 avoids too many chemicals in a confined area or on any one floor is through what I'll refer to as the density provisions. These provisions prevent very small areas from having very large quantities of chemicals and still being considered a laboratory. It's intuitive that a more concentrated flammable combustible materials create a larger potential hazard. And when a space becomes too dense with chemicals, it becomes a chemical storage room, and it's no longer under NFPA 45's purview. But NFPA 45 uses these two provisions, the total chemical quantities and the densities, to classify labs as class A through D in accordance with their hazard.
Andy, along those lines, can you just, for my purposes, explain what class A to class D is, so I know?
Yeah, laboratory classes are based on the two criteria I mentioned, total quantity and the density of chemicals per 100 square feet. So class D is the lowest, so think educational labs. D or C are typically most of your educational labs. And class A is the highest you can go within NFPA 45 before you're considered a production scale, and it'll be governed by other standards. Each lab has a maximum quantity of chemicals allowed in the lab and a maximum quantity of chemicals on a per square foot basis. Your lab classification is based on these maximums. For example, a class D lab might be allowed to have 1 gallon of flammable combustible liquids in use for every 100 square feet, and a total of 75 gallons, while a class C lab can have twice that, and a class A lab might be able to have 10 times that. And you can see on the slide that there are area limitations in NFPA 45, but those are going for class A and class B laboratories, but those are going away in future standards of the code. So as the goal of NFPA 45 is to confine a fire to the lab, as the lab class increases or the lab is located higher in the building, it may require higher fire ratings of the separation walls between lab units. So the chart you're looking at shows how the fire ratings for the lab enclosures change based on the classification of the laboratory, as well as the height of the laboratory within the building. An issue with this recently came up at an urban university that we had a project in that had a small lab on the 7th floor. The city adopted the 2018 IBC, which has those more lenient requirements for higher education occupancies that we discussed, but NFPA 45 was also enforced by reference. The architect on the particular project was comfortable with the building code, but was unfamiliar with the reference to NFPA 45. The space was fully permitted and constructed, and then the fire department came out to do their inspection. And this particular lab used solvent baths on the lab benches with multiple baths in use at any one time, which was noticed and flagged by the inspector. So when I came in and evaluated the space under NFPA 45, I found that the lab required a 2-hour fire rated separation wall to separate it from the other labs in the building. However, it was built with a non-rated wall and a glass door. And the project didn't receive its certificate of occupancy until the door and frame were replaced, and the wall required an extra layer of gypboard on each side to achieve the required 2-hour fire rating. And at the beginning of the project, this wouldn't have been an issue, but at the end of the project, it became a scheduling and cost issue that created a lot of heartburn for everyone involved.
So Andy, Andy, just to interject there a little bit, but we talked about this and we think it's probably somewhere in the neighborhood of $10,000 to $30,000 worth of cost. So going back to that insurance premium cost, well within the cost savings, just based on the cost of construction that was added at the end, but the disruption was even a bigger issue in that case.
Yeah, definitely. And this is that's the bigger issue for this particular one, was definitely the time between when they wanted to be able to occupy the space and when they could. And you know, it's a theme, it's the result of a theme that we're going to keep returning to today, which is that hazardous materials are really one of the first things you have to get your arms around when you're looking at a new building, or if you're a landlord and you're looking at a new tenant, because the first step is understanding the codes that apply to your building and the specific hazards within. In this case, the client and architect were fortunate, really, because the fire barriers required to enclose these hazards must be supported by the same level of fire rated construction. So in this case, a 2-hour fire barrier was required, and it needed to be supported by 2-hour fire-rated construction. And the team was fortunate that the building had 2-hour fire-rated floor assemblies and a structural frame to support it. If not, there would have been no clear resolution. We see this happen often. And in this next example, which is a similar problem, occurred in a straightforward IBC building where the issue was just missed by the design team. In this case, a lab tenant was moving into the top story of a 5-story building, and the building already had a small lab tenant on the 4th floor. Before we get too far into the story, let's talk a little bit about why we see this issue on so many projects. Most project teams are simply not aware of the hazard that their building will present, that their project will present. And in most buildings, the occupancy type drives the design of the space. And if you're building an office building, you classify the building as Group B for business use, and you design your building to comply with the provisions of Group B, regardless of whether it's a lawyer office or a bank or whatever. And there are 2 essential hazards in any building: the building itself, especially if it's built of combustible materials, and the contents. So for a typical office building, the floor and wall coverings are restricted by the code to limit flame spread, and the contents are generally understood to be paper and other general office supplies. These are considered light hazard occupancies, and the fire protection systems are designed to control a fire that might occur. However, most laboratories are also considered B spaces, the same as a common office building. But while office buildings are light hazard and among the most lightly regulated use groups in the code, hazardous materials are arguably the most regulated item in the codes for obvious reasons. And very often, teams consider their laboratories as Group B spaces, but don't fully understand the impact of hazardous materials. And when this happens, they can miss critical design requirements that derail the project. Fortunately, the IBC has multiple requirements that can really assist the end user, designer, landlord, and code official in ensuring the correct design considerations are taken into effect. The most important of which is the Hazardous Materials Report, required by Chapter 4 of the IBC. A Hazardous Materials Report is specifically required for any building that uses or stores hazardous materials. It does not matter if the user believes they're a Group H space or not. It doesn't matter if they have a lot of hazardous materials or not. They are required for any building that has any hazardous materials. The fact that they're not more commonly provided is a significant cause of pain and suffering when projects contain hazardous materials, because they are useful tools for the end user, designer, team, and code official. In our previous presentation, on your previous presentation, I should say, you discussed converting spaces to labs. And the hazardous materials report can really help in that process.
So I guess the real question there is, where does the report come from? How does it get created? If you could shed some light on that, that'd be great, Andy.
Yeah, so I mean, like I said, it's required by the code, and the architect or their consultants put them together to present not only what the inventory is in the space, but the impact of it. And so as you mentioned, these reports are like design insurance for these projects. However, as hazardous materials projects are rare, these reports are rarely enforced by code officials unless the project has a clear and obvious high level of hazard. It seems they're often forgotten, or that the expectation is that the end user understands the hazards of their space, but often that's not the case. Design teams can tend to rely on their end users to understand the hazards of their space. And this works where the end users have large, sophisticated internal safety teams, but many do not have the luxury of such a team. So even those firms that have sophisticated environmental health and safety groups, these teams focus on day-to-day hazard prevention, items that are regulated by the fire code, like oxygen detection, or by NFPA 45 or OSHA, like eye wash stations, fume hoods, lab safety protocols, etc. And unless the client builds labs regularly, building design is likely not an area of expertise for them. And it's the responsibility of the design team to make sure that they understand their hazards, as well as any necessary mitigation strategy, and document it on the plans. And if there'll be any hazardous materials on your projects, you should be complying with Section 414 and preparing a hazardous materials report. It can be as simple as a table on your code sheet, but it's always worth evaluating. Most projects, there'll be no implications, but you won't know unless you look.
So Andy's always very humble in this regard, and he's done a lot of these reports for his clients and for his the building projects he's been a part of, and it's been my pleasure to be part of a few of those with him. really when we don't identify these hazards on the plans clearly or call out the chemical storage rooms on the plans, it can be missed and cause problems in the long run. It creates long-term impact for some buildings.
Exactly right. I mean, on this project, the architect was just unaware of the hazardous materials that their tenant would have. So there was no information on the drawing set, and there was no area labeled as chemical storage. And also the landlord was unaware of the hazard materials that were already present within the building. So neither of these labs considered themselves to have a significant quantity of chemicals. And so it just never got dealt with in any real way. Unfortunately, hazardous materials are highly regulated in the IBC, especially on the upper levels of buildings, anything above the third floor, really. And this is because the IBC regulates hazardous material quantities under a concept known as maximum allowable quantity. And the maximum allowable quantity is exactly what it sounds like it would be. It's the maximum amount of any class of chemical in any one area. These areas, called control areas, must be separated from one another by fire-rated construction. The quantities permitted by control area and by floor are reduced as the chemicals are located higher and higher in the building. And this leads to the biggest hurdle with modern laboratory design, which is the desire for laboratories in premium spaces. This tends to mean putting laboratories on the upper level of a building. With researchers and scientists no longer content to be confined to the first floor or to the basement, labs are commonly found on the upper levels of mid and high-rise buildings. And if we go back to the intent of the codes to provide safety to life and property, as well as a safe environment for responding emergency personnel, we can see how this is an issue. Buildings are easier to exit and fires are easier to fight when they're close to the ground. So when we put hazardous materials on higher levels of the building, we would need more and more robust building systems to meet the goals of the code. So it's logical as we move up the building that the maximum allowable quantities get smaller and smaller.
So Andy, one of the things I always point out is there's multiple ways to solve any problem, right? And you said building systems in your last statement there. And I want to make sure I understand, is there's a difference between building systems like fire-rated enclosures, and maybe it could be applied that in some cases, flammable storage cabinets could be a substitute for increasing or making more robust building systems. Is that a fair statement?
Yeah, that's right. I mean, building systems that allow for higher quantities of chemicals include, sprinkler systems, enhanced, more robust densities, flammable storage cabinets. Sometimes you'll require enhanced fire alarm systems, additional fire-rated walls, among other features that we can talk about a little bit later if we get up to a high hazard occupancy. But yeah, you can look at the issue holistically, and that's really what the code has done, is identified what the hazards are and compared them where they are in the building and come up with solutions that allow them to meet the goals of the codes and standards. So that's where we are in our story. We have a lab tenant on the 5th floor of a building and a lab tenant already within what would be considered the same control area. And under the IBC, their combined chemical use would be limited to the point that it rendered the project unworkable. They couldn't function as an efficient laboratory. So at this point, we'd be grateful for a relatively easy solution like the previous NFPA 45 related example, but where we could build a 2-hour fire barrier to create a second control area and double our chemical allowance on the floor. But in this building, we only had 1-hour floors and a 1-hour structural frame. Now, I should point out, when the issue was discovered, the project was completely through design and had been submitted to the city for review. So when they reached out to me, I did the only thing that could be done other than to scrap the whole project, which was to negotiate a variance allowing for the lab to be located there. The tenant was provided with 2-hour demising walls and 90-minute doors, which were supported by less than 2-hour construction. The sprinkler system was enhanced and all chemical storage was put on the first floor. And at the end of the day, everything was all right, but the impact on the schedule was significant as approval was negotiated.
Yeah, bringing chemical storage down in the building seems like a great solution in many cases, but you do need to limit the real estate on the first floor so you have those options. If you can't move to the first floor, you may have to provide chemical storage rooms at levels above grade. In either case, you may end up with a high hazard occupancy. And in a high hazard occupancy, the cost ramifications can get very complicated, as comprehensive systems for fire-rated systems, walls, and floors would be required.
Yeah, that's right. Yeah, so in the IBC, when we exceed these maximum allowable quantities, as you said, these areas can be considered high hazard occupancies or group H spaces, and they can require some real significant design costs. Group H spaces are not limited to chemical storage rooms, though. So as an example, several years ago, I was asked to consult on a recently completed renovation of a sort of prototyping facility for a cosmetics company. The project had just been completed. It was a simple relocation of an existing space within the same building for logistical purposes. The majority of the building was office space and storage, but there was a small area designated for creating new powdered makeups. And this is a great example, as no one really thought of what was happening as hazardous because they had been doing it for years and they were simply relocating the process. However, once the space was built out, it was actually a representative for their insurance company that commented on the process and asked for a hazardous material assessment report. The client didn't have one and reached out to us to prepare one. As I said, these reports are required by the IBC, and the intent of these assessment reports is for the designer or end user to identify the quantity, classification, location, and use of all the hazardous materials in a building. Remember, the building and fire codes are regulating the building design to try and make sure the contents are not going to overpower your fire protection and life safety systems. These reports attempt to classify and quantify these hazards. Are they explosion risks? Are they fire risks? How much do we have on site? And how do we design our buildings to reduce the hazard? After surveying the facility, classifying the chemicals, and identifying the quantities, it was determined that this room was indeed a Group H high hazard area. It had several containers of highly flammable and potentially explosive solvents like acetone that they used to make their prototype powdered cosmetics. Acetone, as an example, is a very common chemical in laboratory environments, and it can be an explosion risk. And due to this explosion risk, the code required the space to be a Group H2 hazardous occupancy. Ray, as an engineer that designs a lot of these spaces, can you chime in on the implications of that designation?
Yeah, no, I think it's really important. So as you get into H-class occupancies, you're looking at a lot of different variables, but secondary power, emergency power, standby power to support egress, ventilation, and alarm systems. You could also have Class 1 Div 1 wiring throughout and electrical devices, all needed to reduce any spark or any hazard to reduce risk. Mechanical ventilation systems would be typically around 1 CFM a square foot, designated outside air dampers for purge and relief based on the level of hazard based on sensors. You'd have explosion venting for certain chemicals, including Class 1 flammable liquids. You'd have a liquid tight floor. And then in some cases, you'd actually have to go so far as to have spill control, secondary containment, up for the largest vessel in the space, largest hazardous vessel, as well as fire protection water to support putting out a fire. So all of those things can add up to a pretty complicated design and a lot of dollars and a lot of coordination.
Exactly. And interestingly, when I realized the space would have to have a Group H designation, I went over to look at the original location. You know, the exterior building at the original location actually had blowout panels, but over the years, they had been covered up, making them useless for one, but also they were difficult for the internal staff to see, and they just lost sight of the requirement. I'm sure if my client had known about the requirements beforehand, they would have been okay with keeping the room where it was. So Ray just went through some of the design ramifications for a Group H space, and they include some very specific requirements regarding ventilation. But let's talk a little bit about the mechanical implications of laboratories. It's probably the biggest design question we get when it comes to laboratory design within a traditional building. There are several different categories for ventilation, but let's focus on the three most common that we see in a traditional laboratory.
So general lab exhaust. Lab units, must be continuously ventilated. Work areas must be under negative pressure. To non-lab spaces, you may have lab spaces inside of biological spaces that have positive requirements, but anywhere you have hazardous chemicals, you need to maintain that negative pressure space. The second type of space would be the hood exhaust. Hood exhaust is also something that is highly regulated in the code, and it defines the need for fume hood exhaust, ventilated enclosures, and things like that. Exhaust from different enclosures within the lab unit, as well as general exhaust from a lab, can be combined, but exhaust from each unit must be separated and ducted outside. So the way to look at this is to say that if you have a bunch of fume hoods on the 3rd floor, you need to take those fume hoods, you could manifold them together and take them through a shaft all the way to the roof or the penthouse. But it can't commingle with the floor above or the floor below. The one exception to that is manifolded duct systems, where you could use subduct systems, which would then allow the fire rated separation between the fume hood exhaust systems on, say, the 3rd floor and the 2nd floor to commingle, because the subduct will act like a fire separation between the 2 floors. The main thing to remember, and the reason you can use a subduct to separate those 2 things, is that there is no fire damper in a subduct. A subduct is a duct within a duct, and it creates the fire separation for floor separation. Hazardous or hood exhaust cannot house or cannot contain fire dampers. So you can't have a fire damper at the floor, you can't have a fire damper at the shaft. Each one of those ducts needs to go from the space all the way to the roof and protect the fire separation between floors. The hazardous exhaust is the final category, and this particular category is extremely high hazard, and it needs to be dedicated to its own chemical exhaust system. You'll typically see this in things like perchloric hoods, where the fire hazard as 25% of an FLF. This is within an H group space. So whenever you have an H group space, you're going to find yourself having to exhaust that directly to the outside, cannot be manifolded with other systems due to the higher hazard of commingling those chemicals in the duct. Let me pass back to you, Andy.
Yeah, these are all considerations that are dependent on the hazards within your laboratory, and not understanding how your hazards would impact the needs of your space can create significant problems for your project. And so how do we avoid issues like this? For the tenant, we're back to the hazardous material inventory and the assessment report that's required by 414. And if the tenant understands their hazards and the level of protection that they will require, this can be invaluable during the site selection process. They can submit this to the landlord to verify the building can accommodate them, or they can have someone from their site selection team perform a site visit to verify the existing conditions themselves. And a great way for landlords to make sure they're not caught unaware by a tenant's hazardous materials quantity is for the landlord to have an evaluation performed on their specific building to identify limitations within their building on a per floor and per building basis. And this information can be included in any lease agreement and take some of the liability off the building owner in the case that the design team does not do their own due diligence. So the letter would simply outline the maximum allowable quantities on each floor based on the building construction, sprinkler system design, etc. These requirements are relatively fixed for the life of the building, and where a tenant identifies a challenge, they can initiate a more rigorous review of their specific requirements.
So Andy, along those lines, with the when you're dealing with leases and landlords and tenants, there tends to be a lot of lawyers involved. How do you approach that? It seems how do you take a complicated issue and get it through a lease like that?
Yeah,
What's your best suggestion?
Yeah, I would highly recommend that each side engage an expert in hazardous materials compliance. The specifics of these requirements are challenging, and small variations in chemical classification or an understanding how the chemicals will be used in the space can result in wildly different conclusions on how that hazard must be protected and how the building must be designed. Landlords and end users alike should really be considering this part of what I would call the risk assessment master plan. Risk assessment, you need to understand your hazard. You need to understand what it means for your overall risk profile, and you need to know what chemicals the building can accommodate. And this stuff should be hammered out as early as possible. Tenants are best served by fully understanding their hazmat inventory and what fire resistive ratings and building systems are required to protect their people and the building itself from an incident in the lab. This type of preparation can avoid lengthy scheduling delays, project cost increases, and ongoing liabilities. And on the landlord side, landlords are best served when they're aware of the hazards presented by their tenants in their buildings. Once you know the hazards present in your building, you can track those hazards as they change over time and adjust your hazardous materials assessment master plan. I talk to universities all the time about stuff like that, where you can, hazards in labs move, researchers change. This type of stuff requires constant vigilance to be on top of it and make sure your building remains in compliance. And by maintaining this master plan, you'll be able to quickly identify any restrictions on any new tenants and clearly understand the impact that any tenant would have on your overall fire protection and life safety master plan. Also, by tracking this, you reduce your own risk exposure as well as position your building better for educated tenants and for future lab use.
So that's something that it's an ongoing exercise, you're saying, you're suggesting?
Yeah, I don't think it ever stops. I think,
right.
I think it's something that has to be maintained. I mean, you're on the end user side. If your hazards change, you need to understand what that means. And on the landlord side or a building owner side, they need to constantly be aware as hazards change, because as Ray mentioned earlier, there's the building code piece, which governs original design, but there's also the fire code, which can reference 45 or other standards that will vary based on what you're doing in your space. And so you only need a building permit when you're renovating or building a new space, but you can be changing out equipment and hazards, which won't trigger the building permit process, but it will trigger compliance with your fire codes and a lot of the reference standards. And if you're not keeping up with that, there might not be anyone babysitting you and enforcing that you change these requirements based on the changes in your labs, but you need to maintain compliance with these codes and standards from your own standpoint, from a liability standpoint, from a life safety and fire protection standpoint as well.
Great, thanks.
So Andy, you referenced several times, and we've talked about the low cost of insurance to create these master plans and to confirm, where the risks are. And I think it's this idea of controlling schedule, risk, cost. All of those things are important to every project and every stakeholder in every project. So having somebody like yourself involved is really important. These plans really are not about the tenant. They're not about the landlord. People need to remember a lot of these plans are about making these places safer to live, safer to work. Remember that these people, if anything was to happen, you need to make sure that you can get out of the building safely, and that the people that are trying to save you in that condition can get into the building and save you. Really important. And buildings that have tenants that want to be in the lower level, and a building that has a tenant that wants to be in the lower level spaces least, but the upper floors have capabilities for labs too. People push that higher weight equipment, higher hazard equipment to the lower level, but it can work in the upper floors if planned properly. It's important to make sure that the teams work together, that they coordinate these things. We don't know exactly what chemicals are going to be used as designers, as architects and engineers. We need people in the life safety code consulting practices to help push the end users to explain how they use their labs and what the real risks are and what chemicals they have. This will limit the risks and help keep the things in line, on schedule, on budget.
So Ray and Andy, we got some questions. We love questions. It keeps it interesting. There's a question out here. Is the design team / architect liable if the client changes their chemical inventory and hazard index months or years later?
Yes.
So I guess the question is a timing. Is it like, how good is, how I would ask, yeah, I would agree with you, Ray. It's yes, probably. But how long is it good for, I guess, is it the variable of time in this whole design process?
I think the, liability is tough because, lawsuits can happen and there's really no rhyme or reason. But I think the key thing for any design team to do is to just document that they did their due diligence, that they did their job properly, and that they designed their space to protect against the hazards that they were aware of at the time of construction. It's it gets down to, you know, a headline test. Like if something happens and push comes to shove, can you document that you did your stuff right? Because if not, the headline isn't going to be that, you know, we promised it was right 2 months ago. The headline is going to be that you know, there was a fire and that you were the architect of the design team of record. So you want to make sure that you can cover your bases and you can show that you did everything that you could do, that you followed the code, and that you understood the hazards and designed against them.
Can I add to that, Dave, if I can?
Sure.
So all the education we've thrown at you guys today goes in hand with the education of the client and the building owner at the time of the design. So if they think they may have increases in chemicals or flammable storage over the life of their building or the growth of their business or the research that they're performing, we would want to try and see if there's ways to future-proof against those things. Andy, you talk about the master plan. I love when you talk about the master plan of a building, because if you know what those things could be in the future, it may be really inexpensive to fix it day one. But if you don't know about it, it's always expensive to fix it day end when that hazard shows up. That's been my experience anyway.
No, I would agree. And sometimes you'll get there where people will say, well, we only have 4 gallons and our maximum's 5, you know, and that's the type of stuff where you have to really consider how the use of this building is going to change over time. And are we always going to be at 4 gallons? Because it doesn't take much to go from 4 to 6. And then you flick a switch that requires a whole lot of new requirements, which you said, Ray, becomes a lot more expensive on day end than it is on day one. All right. So, you know, I think that just gets back to how important these assessments are, you know, and they're, like you said, they're easy and they're inexpensive. And I know that, you know, my experience with these projects over the years, including the issues that I've mentioned throughout, has biased me. But the lack of the widespread use it's baffling. I mean, for, as you said, you know, 5 to 10 grand, you can assure yourself that your project and your building won't run into these issues. They're an essential part of any due diligence, and they pay for themselves in the risk mitigation alone, not only to protect the space, but to prevent the, you know, to at least limit the ongoing liability that Dave mentions for all the relevant stakeholders that are involved. So, you know, in conclusion, from, you know, hazardous material compliance in laboratories, it requires experience in many different areas. You know, some chemistry knowledge is required to classify your chemicals. Environmental health and safety experience can assist in understanding the requirements within the fire code, NFPA 45, and even OSHA. You know, building code experience is needed to be able to translate and coordinate various requirements from several often conflicting codes and standards. And of course, MEP engineering and architecture expertise is critical, like they are to the success of any project. You know, and these standards are a comprehensive way to involve stakeholders. These reports, I mean, are a comprehensive way to involve stakeholders from all these groups with experience in laboratory design to put together a comprehensive strategy to address hazardous materials that's fluid enough to handle the variable challenges that your project and facility may face.
I think there's not much questions, but anybody else? I think the mics are open. Am I correct? Anybody else verbally want to throw out a question?
I don't have a question. Can you hear me?
Yes, we can. Thank you.
This is Anahita Razavi from Harvard University, Thompson Facility Services. This was great, very, very helpful. I'm currently doing a lab project. It's a physics lab. I'm not doing chemistry. But thank you so much for bringing out the NFPA 30, which I'm working with architect, and this is basically architect and their engineers. So I want to make sure that we are all covered with that part as well. So thank you. This was extremely informative. Thank you so much. And I have the website open, looking at all this different codes for NFPA. So this was really informative for me. So thank you. And I hope I will pass the safety inspection. So I'm going to actually, after this, I'm going to be calling them.
That's terrific. Yeah,
truly.
we didn't want to scare everybody with Andy's. He's got story. He can go for another hour on the stories about the issues about the fire marshals and et cetera, et cetera.
Yeah.
And I think the point that Andy and Ray made, it's the cost in comparison of spending it up front is a lot better than spending it afterwards. And I agree with you.
I agree with you. And Ray's pretty much aware of how we operate here at Howard University. We have very limited budget, but we constantly try to bring him bring him over and have him to do stuff here to prevent the extra costs at the end. But we shall see.
We wish you well on your inspection. And as always, if you have any issues, we're happy to be here to help you.
Thank you. I was gonna send you the CDs right now, but first I'm gonna check with the architect. But thank you so much. This was really informative. Thank you.
Thank you. Anybody else? Anybody? I think we're right on almost a little bit of time, but we appreciate everybody. We're going to be sending slides and video recording for the next couple of days. And also, if you could, we enjoy doing this. We enjoy the interaction. Anything in the surveys that you can say positive or negative that might help us do make a better job. And this is the second of the series. And we're going to keep doing this. And we've gotten so many calls from people just to keep, like I said in the beginning of the conversation, COVID, there's a ton of questions about COVID, which led to life sciences, which led to repositioning. So there's a lot of questions out there in the marketplace, especially nowadays. So I thank everybody. And anything else, Ray and Andy, thank you very much.
Just want to say thank you. It was our pleasure. Obviously, call or email. If you have any questions on projects, we're happy to be here to support the community to make the building safer, help our life safety professionals in the marketplace, and also help the occupants and the fire departments help keep buildings safe.
Great. All right. Thank you, everybody.
Thank you, guys.
Thanks. Bye-bye.
Bye.
Thanks.